Hey folks, welcome to the channel. Today we're converting a wood bandsaw into a metal cutting bandsaw. This is your typical small benchtop bandsaw. This one happens to be a Porter cable. However, what we do here should apply to any of these small benchtop bandsaws. Let's open it up and see how it works. On the top here we have an upper wheel. We also have a lower wheel, and the blade goes around both wheels. It's driven by a motor. You can just barely see the pulley on the left of my hand, and a belt, and it drives the lower wheel. And that's pretty much it. Okay, let's get to the gist of what we're doing here. When you're cutting wood, this blade zips along pretty fast. It goes 2,500 feet per minute. However, if you want to cut metal, depending on the type of metal, it varies depending on aluminum or steel, brass, whatever. But you need to be in the ballpark of 250 feet per minute. So we need to slow this down 10% to 10% of the original speed. 2,500 needs to come down to 250. So that's what we're going to do. First thing we need to do is release the tension on the belt. Then we can remove the belt. All right, there's a little snap ring. Take that off first. And the pulley attached to this wheel is the small pulley in the back. We'll just take these screws out, then we can pull the wheel off, and then the pulley and belt should be sitting there. Now I'll close this up. Okay, there we are. I can take the wheel off. There we go. Let's look at that pulley there. You can see the pulley and the belt. That's a small serpentine belt, and that's a plastic pulley. Let's take a look at that. All right. You can see this serpentine belt, or serpentine pulley, and this pulley just fits right here. Fits on that machine surface, and it's got a little bit of a relief there, and you can see how the shape of it's raised up to clear the casting right here. All right, serpentine belt. 4 teeth wide. Now let's try to get in there and look at that pulley there on the motor. So that's a pretty small, that's 27 millimeters, a little over an inch. There isn't a whole lot of room in there to fit certainly we can't fit a bigger pulley. We can't do much there. What we can do, however, is go to a 2-stage pulley. So essentially what we would have is the original motor pulley, an idler pulley, and then we can have a bigger pulley to replace this. There's only 2 spots really for the idler pulley to sit. We can't fit any up here. This is where the belt comes out, and the the blade comes here. So the blade, we can't put anything here because the blade's right there, and same thing here. We can put something down here, and we can also put something right in there. This side probably isn't a good candidate because the motor is there, so our belt would be very, very short going to that pulley. But so that pretty much leaves this area down here for an idler pulley. And the idea of the idler would be, we would make one stage of reduction going from the small motor pulley to the back part of this idler pulley, and that would be a larger diameter, so we'd get a reduction there. And then on the other side of the idler pulley, we'd have a small pulley in front of the wheel here, and then we would have a larger pulley mounted to the front of the wheel. So instead of the pulley getting driven from the back side, we would now drive it from the front side with a larger pulley. So that's going to be our plan of attack here. We're going to 3D print the idler pulley over here, and then we're going to 3D print the pulley for here. All right, let's take a look at our first attempt. Here's a drawing of the belts and the layout. So here's the motor pulley. This is the wheel. We have an idler pulley here. Here's the large pulley. Here's the small pulley. And then finally the larger pulley on the opposite side of the wheel. Let's take a look at the outer pulley. So it turned out, looks pretty good. Serpentine, and looks great when it's modeled. And here's the idler pulley. So these models look great. The problem came printing them. So let's look at what happened there. Okay, here we have the 3D printed pulley. And this is the large pulley for the wheel. And the problem, as you can see, is the resolution of the serpentine teeth are not very distinctive. Next up is the idler pulley. This is one attempt. You can see that the resolution on the teeth weren't very distinctive again, and this had some other problems. One approach I took was to just print the pulley without teeth and then try to cut the teeth afterwards. Here's a cutter tool that I purchased to cut the serpentine belt grooves. Didn't work out very well. Carbide's not that sharp. I had welded an extension on it because the tool I purchased was for a larger lathe. So I made it fit my lathe. But in the end, it didn't work out. There's another consideration with printing these idler pulleys, and that's the strength. You can see that, it's not a great video, but you can see that the top pulley there, the small one, sheared off. So in our new design, we're going to have to accommodate for that, because that's in 3D printing, the adhesion between layers is the weakest part of the 3D print. And unfortunately, that's along the plane that we're going to get the most twisting force. So we have to account for that in our new design. In part 2, we're going to use a 5M timing pulley rather than the serpentine pulleys. If you like the content, please like and subscribe or leave a comment. Thanks for watching. See you in part 2. Take care.